All right, so we're going to talk about asymptotes. And there are two different types that we're going to talk about today: vertical and horizontal. Now, I like to talk about this unit as the MC Hammer unit. Y'all may be too young for this, but MC Hammer wrote a song called Can't Touch This. No. And the idea of an asymptote, especially the vertical ones, is that you can't touch this. So the asymptote here is, let's change the color of our little dealio, and maybe make our line thicker. So this is the asymptote, and you can't, like, the line will never touch it, right? But there are horizontal asymptotes as well, and so that's like this one. And the weird thing about horizontal asymptotes is that they are mostly talking about the tail behavior of the graph. In the middle, you can actually touch it. So it's kind of like a pseudo MC Hammer. But what I would like for y'all to think about is that we're going to pair MC Hammer with Where is Waldo? So you want to find out where these asymptotes are. And I'll show you an example. So if I have a graph that looks like this, right? So there's, let's say down here, there's a little shenanigans. And then let's say there's something like this. Maybe this is a bad example, but the question would be, where are the asymptotes? Why is my video being weird? Okay. And the easy one is this vertical one, right? And then the horizontal one you can see on this side, right? So that would be y equals 0 there. And this one's a little complicated on the other side. But anyways, let's go another one. So let's see what these things look like whenever you're going to find them in the wild. And basically, it's dividing by 0. It's a classic, explosion of mathematics. So if I have a function y equals 5 minus x over x plus 2, x minus 1, right? So the first thing is zeros on the bottom. That is how you get a vertical asymptote. So if we think about where those zeros are, -2 and +1. So we're going to have asymptotes there. Now, when you think about the long-term behavior, if you see there are 2 x's on the bottom and only 1 up top, power-wise, that's going to go to 0 because the bottom's going to grow so fast that it just flattens out. And so our asymptotes are going to be this line and these two vertical ones. Now, if we want to find out, okay, now where else are there things? Well, you also look for zeros up top. Zeros on top. So 5 minus x is going to be a 5. 1, 2, 3, 4, 5. Going to have a 0 there. And then you just kind of play with what numbers look like. So if we get close to this one, if we plug in a number that's like just a little bit bigger than 1, you can see that that's going to be positive and that's going to be positive. So both of these are going to be positive, and this guy is going to be positive. So this is going to be up here. And then if you think about a really big number, like 1,000, that's going to be negative, positive, positive. So we're going to be doing something like that. And we're going to get really close to things there. Then on this side, if you think about something really close to 1 on the negative side, that's going to be negative, positive, positive. And so this is going to be negative here. And then really close to negative 2, so like negative 1.9, is going to be the same thing. So it'll be something like that. And then really close to negative 2 on the other side, negative like 2.01, negative, negative, all that's going to be positive. And so you end up with something like that. So we have figured out what the graph looks like, all from looking at what are our asymptotes vertically, what are our asymptotes horizontally, and then what possible zeros and stuff like that are there. So let's do another one. But I want to show you something else. So let's do 3x squared plus 2x minus 1 over x squared plus 4. Let's do minus 4. So we have some asymptotes that are easy to see. All right, so first off, this is x plus 2x minus 2. We should recognize that pattern. So if we think about our asymptotes here, so we know we've got this kind of a shape. I don't really want to factor the top to figure out zeros, but the key thing I wanted to show you is the horizontal behavior. So if you think about, you've got this x squared and this x squared. Those are going to grow at roughly the same rate, and then these are going to become less important over time. And so if you think about the ratio of those, is going to come out to basically 3. And so we're going to have a horizontal asymptote at y equals 3. Another way you could look at this is if you do division, you'll see that it'll come out to basically that, right? So if you did like 3x squared plus 2x minus 1 divided by x squared minus 4, right? That's going to go into that 3 times 3x squared minus 4, 12, I guess, minus plus. So you're going to get 2x plus 11. 2x plus 11 over x squared minus 4. So you can see how this is going to ultimately go to 0 over time. Like this guy is going to get smaller and smaller and smaller over time. And then that guy's just going to stay the same. So that's how this becomes a horizontal asymptote. And so now let's plug in our random numbers. So if we think about, I'm getting close to 2 from this side, from here, from the right, then I'm going to get like 2.01, positive, positive. This guy is going to be positive. And so we're going to have this behavior. And then we're going to end up going to there. I guess it could be above. Anyways, 6 of one, half dozen of the other, right? And then on the left side, we're going to have 1.99, negative, positive, positive. So we're going to be negative like that. Same thing with negative 2. On the positive side of that, it's going to be positive. Yep, same thing. Something like that. And then from the negative side, so negative, negative. I think that's still going to be positive. Yeah. So it'll still be positive. So it'll be something there. So anyways, hopefully that is helpful. A lot of the big picture is check signs and close to behavior. And just to dig in on that a little bit, if you think about at one of these asymptotes, right? As we get really close, like if I had, I don't know, let's just do 1 over x since it's simpler. When this number gets really small, right? 1 over, let's just say like 1 over 1 with a bunch of zeros, right? Remember, keep, change, flip, stay, change, flip. That's ultimately going to become a big number. Same if it's negative. Right? They keep, change, flip. It's going to become a negative really big number. And so that's how we end up with this behavior going up to the sky and down to the ground. And so this is what the y equals 1 over x kind of classically looks like, is this alternating dealio, versus like a y equals 1 over x squared would look more like that, because it's always going to be positive. So, hope that's helpful. Give it your best shot, and it should be fun.